Good morning, students. This is B. Srinivasarao, Department of Electronics from TJPSC College. Today we are going to discuss about microprocessor. Microprocessor. Microprocessor means microprocessor is a programmable integrated logic device. It has a computing and decision making capability. Okay, first of all we see the microprocessor. Microprocessor means microprocessor is a programmable integrated logic device that has a computing and decision making capability. Here the microprocessor, depending upon the program, it can perform the program. Here integrated means all the peripherals are integrated on a single chip. All the peripherals are integrated on a single chip. Here the logic device, it can perform the logical operations and arithmetical operation. That is known as the logic device. The microprocessor means programmable integrated logic device. Okay. It that has a computing and decision making capability. It is can perform the calculation part. It making decision. Decision means whether the condition is true or false. It can be depending upon the decision. Whether the condition is true, at that time it will execute. Otherwise, it will not execute. It can be depending upon the decision making capability, and it can also perform the calculation. Okay. Microprocessor means programmable integrated logic device. It has a computing and decision making capability. Okay. Microprocessor. Microcomputer means the microprocessor is combined with memory, input and output devices. It can perform the microcomputer. Microprocessor. It is also called as a micro. It can written as mu. Processor is also written as P. Okay, microprocessor simply we can written as mu P. The mu means micro, P means processor. Okay, this is the microprocessor. Microprocessor is the small integrated chip or mini. Okay, then we can call it as micro. It can be written as mu. Processor, it can perform we give the input and the processing, and then it can produce the output. Processor, it can processing the inputs and outputs. Okay, then it is called as a microprocessor. Okay, microcomputer. The microprocessor is combined with input, output with memory. The microprocessor is combined with memory and input output device. Then it can form the microcomputer. Then input, it gives the input to the keyboard. Here the microprocessor is nothing but a CPU, central processing unit. Here microprocessor is nothing but a CPU. The microprocessor gives the information to the memory, and the memory can store the information formation of microcomputer. Microprocessor is combined with memory and input-output devices. You can call the microcomputer. What is the difference between a microcomputer and digital computer? Digital computer. Microcomputer and digital computer. Here the CPU, central processing unit, is combined with memory and input output device. This is the digital computer. This is the digital computer. There is a major difference between the digital computer and microcomputer. There is the CPU, here the microprocessor. Okay, microprocessor is nothing but a CPU. The CPU replaced with the microprocessor with memory and input-output devices. Then we call the microcomputer. Microcomputer. Okay, microcomputer can understand the information. Can be represented by the binary form, either zeros or ones only. Either zeros or ones. It can understand the information in the binary form. It can be represented by either zeros or ones only. That language is the machine language. Okay. First of all, we will discuss about the basic microprocessor. Basic microprocessor of 8085 microprocessor. 8085 microprocessor. 8085 microprocessor is designed by Intel Corporation of USA. 8085 microprocessor is designed by Intel Corporation of USA in 1976 by using the NMOS technology. By using the NMOS technology. 8085 microprocessor is designed by Intel Corporation of USA in 1976 by using NMOS technology. Here the NMOS technology, N-type metal oxide semiconductor technology. We can use for in which technology? NMOS technology. Okay? In 8085 microprocessor, we can use in which technology? NMOS technology. NMOS. N-type metal oxide semiconductor technology. Here the 8085 microprocessor, it is also called as a 8-bit microprocessor because the processor can accessing the data only 8-bit of data at a time. Only 8-bit of data at a time. Here the processor can work or accessing the data only 8-bit of data at a time. Then it is called as an 8-bit microprocessor. In 8085 microprocessor consisting of registers also 8-bit registers. 8-bit registers. It can perform, it can work, it can access the data. Only 8-bit of data only. That's why 8085 microprocessor is also called as an 8-bit microprocessor. Okay. Next, 8085 microprocessor has following the configurations. 8085 microprocessor is also called as 8-bit microprocessor. 8085 microprocessor consisting of 8-bit data buses. 8-bit data buses from D0 to D7. D0 to D7. D0 to D7. Further, microprocessor consisting of 8 data buses. Those are, here we can see the D0 to D7. D means data buses. What is the bus? It carries the information from one part to another part. From one part to another part. Then it is known as the bus. Here the how many types of buses in 8085 microprocessor? Any processor. It consisting of 3 buses. First one is the address bus, second one is the data bus, and third one is the control bus. Data bus, it can send the data, it can send or receive the data through the data buses. Okay, in 8085 microprocessor consisting of how many data buses? 8 data buses. Those are D0 to D7. In each data bus, it can transmitting or sending the data either 0 or 1. It can be represented by either 0 or 1. How many possible combinations? 2 possible combinations. How many possible combinations? 2 possible combinations. In data bus can transmitting or receiving the data either 0 or 1. These are 2 possible combinations. How many data lines? 8 data lines. How many data lines? 8 data lines. 8 data lines or data buses. 2 power 8. 2 power 8 means 256. 256. In 8 data buses, we can transfer, we can send or receive the data, can be represented by either zeros or ones. Okay, it can be denoted by 8 zeros to 8 ones. 8 zeros to 8 ones. Here 4 zeros can be represented by 0. 4 zeros can be represented by 0. Here the binary form can be divided, can be converted into the hexagram. Okay. Here 4 ones can be converted. Here 4 ones can be converted ones. And the binary value can be converted to hexa. And the data can send or transmitted from 00 hexa value to FF hexa value. Here which is the hexa value? The data can transmitting or receiving from 00 to FF only. 00 to FF only. And next one, in 8085 microprocessor consisting of how many address lines? 16-bit address lines, address buses. Address bus. Here the data bus is the bidirectional bus. It can transmitting or receiving the data. Address bus is the unidirectional bus. Address bus, it can send the address to the memory only. Address is the unidirectional bus. Address, it can send the address to the memory only. Okay, then address bus is the 16-bit address bus from A0 to A15. We can see the 8085 microprocessor functional block diagram consisting of A0 to A7 and A8 to A15. A0 to A7 lower order address lines and higher order address lines. Those are combined with A0 to A15. Each address bus, each address line, we can send the address. It can be represented by either 0 or 1. How many possible combinations? 2 possible combinations. How many address lines? 16 address lines. Okay, 2 power 6 into 2 power 10. 2 power 6 into 2 power 10. And the 2 power 6. 2 power 6, 2 power 4, 2 8, 8 to 16. 62, 32, 32, 64. 2 power 6 means 64. 2 power 10 means kilobyte, 1 kilobyte. 64 kilobyte. The 1 kilobyte is equal to 2 power 10 bytes. 2 power 10 bytes. Here 2 power 10 is represented by 1 kilobyte. 1 kilobyte is equal to 1024 bytes also. 1024. Here 64 kilobyte into 1024. 65,536 memory locations in memory. Okay, how much memory can supporting? How much memory can supporting to the microprocessor, 8085 microprocessor? Here, 8085 microprocessor can supporting the 64 kilobytes of memory. 64 kilobytes of memory. In that 64 kilobytes of memory, how many memory locations? 65,536 memory locations. Okay, in this value is converted to the hexa from 4 zeros to 4F hexa value. Okay, here According to the how many address buses? 16 address buses. 16 address buses. Okay. In each address bus, we can send the address either 0 or 1s. In 16 address buses, we can send the zeros or 1s. Okay. 16 zeros. 16 zeros and 16 ones. Here the simply we can return as 4 zeros is converted to the binary form to hexagon 0 0. Okay, 4 ones we can simple return as 4 ones is converted to the hexagon f 4 ones we can return as f 4 ones we can return as f. In 8085 microprocessor through the address bus we can send the address from 4 zeros to 4F only. 4 zeros to 4F only. Okay, in 8085 microprocessor consisting of 16-bit address buses from A0 to A15, 0 to 15. We will count them 0 to 15. It is 16. Okay, in each address line we can send the address. It can be represented by either 0 or 1, two powerful combinations. Here then we can return as 2. Here how many address lines? 16 address lines, 2 power 16. 2 power 16 to 2 power 10. Here the 2 power 10 means 1 kilobyte. 2 power 6 means 64 kilobytes. 8085 microprocessor can supporting the 64 kilobytes of memory. 8085 microprocessor can supporting the 64 kilobytes of memory. In that memory, how many memory locations? 65,536 memory locations. Memory locations in memory. Memory locations in memory. Okay. We can send the address from 4 zeros to 4F. We can send or receiving the data from 00 to FF through the data bus. Here the address 40 to 4F through the address bus. Okay. 8085 microprocessor can require the power supply. How much power supply? Plus 5 volts power supply. Plus 5 volts power supply. It can operate the how much frequency? 3 megahertz frequency. Approximately we can take as 3.2 megahertz frequency. You can operate the frequency 3.2 or 3 megahertz frequency. It can require the power supply plus 5 volts power supply. It can operate the frequency 3 megahertz frequency. In 8085 microprocessor consisting of 16-bit program counter register. These are the configuration of 8085 microprocessor. Program counter. Simply we can return as PC. P means program, C means counter. 16-bit program counter. Here you can see the program counter, 16-bit program counter. What is the use for the program counter in 8085 microprocessor? Program counter is the 16-bit register. What is the use for the register? To store the information temporarily. To store the information temporarily. We can take that. We can give the data 10, and another data we can give the 11. At that time, 10 will be erased, 11 will be stored, and another data we can give the 12. At that time, 12 is in store, 11 will be erased. Here the register means to store the information temporarily. Temporary information can be stored in the register. Here the how much bit it can store? 16 bit of information can be stored. Okay, what is the program counter? What is the program counter? What can do the program counter in 8085 microprocessor? Program counter is a 16-bit register. Program counter, it can store the address of memory. Address of the memory. Next instruction is to be executed. Program counter is a 16-bit register. Program counter is always to point the address of the next instruction to be executed. Program counter is always next instruction of the address is stored in it. Address of the memory address. Memory address of the next instruction. next instruction is fetched or executed. Is to be executed. Program counter is a 16-bit register. Program counter is a 16-bit register. It can store the address, it can store the memory address of the next instruction to be executed. The program counter is a 16-bit memory address is stored. Okay. Program counter is the 16-bit register. It can store the memory address of the next instruction is to be executed. Next one, stack pointer. Stack pointer is also a 16-bit register. Stack pointer. Simply we can written as SP. SP means stack pointer. S means stack, P means pointer. This is also one type of register. How much register? 16-bit register. It can store the address of the top byte of the stack. Top byte of stack. Stack pointer. Stack pointer is always pointing to the address of the top byte of the stack. In stack, top byte of information of address. Top byte of address is stored in the stack pointer register. And the program counter is a 16-bit register. It can store the memory address of the next instruction. Memory address of the next instruction is stored in the program counter. Program counter, it can be written as PC. Stack pointer, it can be written as SP. Okay. These are the special purpose registers. And the general purpose registers. General purpose registers are A register, B register, C register, D register, E, H and L. A means accumulator register. B, C, D, E, H, L. Those are the general purpose registers. These are also registers. It can store the information temporarily. How much of information? 8-bit of information, 8-bit of data. It can store the 8-bit of data only. These are the 8-bit registers. These are the 8-bit registers. 8-bit registers. Okay. A register, B register, C register, D register, E register, H and L. Those are the 8-bit register. It can store the 8-bit of information only. It can store the 8-bit of information only. These registers can work in register pair. Register pair. Register pair. You can store the 16-bit of data. These register pair combination, like B register is combination with C register, E register is combination with E register, H register is combination with L register. This is the A register. Those are the individually 8-bit registers. Those are individually 8-bit registers. These are 8-bit registers. These registers can work also pair. Register pair. It can store the 16-bit of data. These register pair is combination with B register. B register is combination with C register. B register is not combination with D. B register is not combination with L. Okay. B register is combination with C register only. These register is known as the register pair. It is the 16-bit register. 8 plus 8. 16-bit register. 8 plus 8, 16-bit register. It can store the 16-bit of information. Here the D register is combination with E register. This is also register pair, 16-bit register pair. Here the H register is combination with L register. This is also 16-bit register pair. Here the HL register pair can access the memory location or memory address of memory. Memory address. It can store the memory address. So the default memory address can be stored in HL register. HL register can access the memory address by default. By default, memory address can be stored in HL register only. Here the BC register, DE register, HL register. Okay. A means accumulator register. A means accumulator register. Accumulator register, 8-bit register, B register, C register, D register, E register, H register, and L register. Okay. Next, 8085 microprocessor. It is the 8-bit microprocessor. 8-bit microprocessor. 8085 microprocessor consisting of 8 data buses. How much data can receive or send from 00 to FF? 8085 microprocessor consisting of 16 address buses from A0 to A0 to A7 lower order address, and A8 to A15 those are the higher order address. Okay, these are to combine with A0 to A15. How much address through the address buses can send to the memory from 0 to 4 zeros to 4F? How much memory can supporting to the 8085 microprocessor means here the 64 kilobytes of memory can supporting to the 8085 microprocessor. Okay, 8085 microprocessor consisting of 8085 microprocessor can require the plus 5 volts power supply. 8085 microprocessor can operate the 3 MHz frequency. 8085 microprocessor consisting of 16-bit program counter. Program counter is also called as a PC. What is the use for the program counter? Program counter, it can store the memory address of the next instruction. Next instruction of the memory address is to be executed or fetched. Okay, next 16-bit to stack pointer. Stack pointer is also a 16-bit register. What is the use for the stack pointer? Stack pointer is always to pointing the address, memory address of the top byte of the stack. Top byte of the stack. How much register? 16-bit register. You can show the 16-bit memory. You can show the 16-bit memory address. And the general purpose registers: accumulator register, B register, C register, D register, E register, H register, L register. Those are the general purpose registers. These are the 8-bit register. Okay, these are the can individually 8-bit register. You can store the 8-bit of information only. 8-bit of information only. Accumulator register, B register, C register, D, E, H, L. These registers can work in 16-bit also. You can show the 16-bit of data. These registers are paired combination, like B register is combination with C register, D register is combination with the E register, H register is combination with L register. At that time, those registers acts as a register pair. That is the 16-bit register pair. You can show the 16-bit of information. Okay. Next, we will continue the next section. Thank you.